Here we discuss the next point, the distribution of the molecular speed. That term we explain from the Maxwell-Boltzmann distribution law for speed. Hence, first term we explain what is Maxwell-Boltzmann distribution curve, and from that curve we explain these 3 points: most probable speed of the molecule, average speed, and root mean square speed of the molecule. As we know, this most probable, average speed, and root mean square speed, then we define the relation between them. Now first see the Maxwell-Boltzmann distribution curve for molecular speed. To explain that term, we use the Maxwell-Boltzmann distribution law in terms of momentum, and that relation is n of p dp equal to 4 pi n into bracket 1 divided by 2 pi mkt raised to 3 by 2 into exponential minus p square divided by 2 mkt into p square dp. That relation we convert in terms of the molecular speed. For that we use momentum relation, momentum p equal to m into v, therefore differentiation is mdv. Substitute that value and we get the equation n of v dv equal to 4 pi n into bracket 1 divided by 2 pi m kt raised to 3 by 2 into exponential minus m square v square divided by 2 m kt into m square v square m dv. Here the exponential term 1m numerator and denominator get cancelled and simplify all the terms, and we get the equation n of v dv is equal to 4 pi n into bracket m divided by 2 pi kt raised to 3 by 2 into exponential minus m v square divided by 2 kt into v square dv. Use that relation and plot the distribution curve. That curve is plotted n of v, number of molecules, those having the velocity in between v and v plus dv, versus velocity v, number of molecules versus velocity for this molecule. Then we get a one curve. That curve explains how many molecules possess most probable speed, average speed, and root mean square speed. Now we interpret firstly that curve. When v equal to 0 means as velocity v is 0, no any particle found that velocity equal to 0, that means n of v is to be 0. Secondly, if we consider small velocity range, that means small values of v, the n of v how vary in that case, that we explaining here. The exponential term is mv square divided by 2 kt. If v is very small, for smaller value of v, that term is to be very less than 1, means exponential term becomes 1, and if exponential term is 1, then the number of molecules, those having velocity between v and v plus dv, is directly proportional to v square. Hence, as number of molecules whose velocity is v, it increases parabolically with increase of v, and it attain the maximum value for particular value of v. That maximum value for particular velocity, that is known as most probable velocity. Hence, what is most probable velocity definition? The speed possessed by maximum number of molecules is called most probable speed. Then we explain what is the effect of large values of v on that distribution. V is large means mv square divided by 2 kt becomes very large. Means what about the exponential term? Exponential term we keep, it is the variation n of v directly proportional to exponential minus mv square divided by 2 kt. It shows that the number of molecules having the velocity v, it goes on decreasing exponentially, since negative sign indicate goes on decreasing exponentially with increase the value of v. And how much it decreases? As v goes on increasing. Now then we find each and every term, most probable, average speed and Vrms term. For that we firstly define what is the probability that the molecule which possesses the speed v. How we calculate that probability? Number of molecules, those having velocity in between v and v plus dv divided by total number of molecules. It gives the probability term. That probability is related to Wv. Hence, the above equation we write in terms of n we take only on the other side, other terms keep as it is. 4 pi into bracket m divided by 2 pi kt raised to 3 by 2 into exponential minus mv square divided by 2 kt into v square. Now then calculate the most probable speed of the molecule. That we calculate by differentiating the probability term, means d by dv of wv, and that probability, if it reaches maximum, its derivative is 0. Hence we use the equation derivative of wv must be equal to 0. Actually we differentiate the above term 4 pi m divided by 2 pi kt raised to 3 by 2 into exponential minus mv square divided by 2 kt into v square. That term we differentiate. Constant term we take outside. These are 4 pi into m divided by 2 pi kt raised to 3 by 2 into d by dv of v square into exponential minus mv square divided by 2 kt. Initially we differentiate v square term, keep the exponential term as it is. That means twice v into exponential minus mv square divided by 2 kt. Secondly, keep v square constant and differentiate exponential term plus v square into, what is the exponential differentiation? Exponential into the coefficient of v square, v, but initially we differentiate v here, v square, that is the twice mv divided by twice kt into exponential minus mv square divided by 2 kt into v square. Now simplify this differentiation of that term and we get the equation v square equal to twice kt divided by m, or v equal to under root twice kt by m. That v is the most probable speed. Is the speed possessed by the maximum number of molecule, that is most probable velocity, and it is given by the equation A. Secondly, find average speed of the molecule. Now how we find the average speed? Suppose the given number of molecules n of v dv has velocity v, and if we calculate for all particles, all molecules, velocity of all that the molecules, out of these are the out of n molecules, and express that relation in terms of probability. That means the average velocity v bar equal to 1 by n. Out of n, how many we select? N of v dv. These molecule has velocity v, and if we integrate, we get total velocity of all gas molecules. That is the average velocity. Hence 0 to infinity v w v dv. Differentiate the term, integrate the term 4 pi into m divided by 2 kt 2 pi kt raised to 3 by 2 into integration 0 to infinity v cube into exponential minus mv square divided by twice kt dv. Here we use the standard integration, which is in the form x cube into exponential minus a x square, where a is m divided by twice kt. Exponential result is 1 divided by 2a square, means 1 divided by 2 into bracket m divided by 2 kt bracket square. Now simplify that term and we get the relation v bar is equal to under root 8 kt divided by pi m. Now that average speed we write in terms of most probable, hence under root 8 kt by pi m we split such as 2 divided by under root pi into, since 8 is 4 into 2, 4 into 2, 4 root 4 is 2, take outside, root pi is as it is. What is the remaining term inside the root? 2 kt by m, and 2 kt by m is the most probable speed. Now we simplify 2 by root pi and it is to be 1.128 times of most probable speed. Hence average speed is to be how much? Average speed v bar is equal to 1.128 into most probable speed. That is the relation B. Thirdly, root mean square speed, that is VRMS. How we find? That is the number of given molecules, those have velocity in between v and v plus dv, out of n has velocity equal to v square. If we integrate that term, we get root mean square speed, average root mean square speed, that is v. Firstly we find v bar square, means it is the average square average velocity. In the same manner, put the value and simplify the integration term by keeping constant term outside and use the standard integration x raised to 4 into exponential minus a x square dv. Integration of standard integration is 3 by 8 into pi by a cube raised to half. Simplify that term and you get v bar square equal to 3 kt by m. Again 3 kt by m convert in most probable speed. Hence v bar square equal to, we write here the v bar, that means root 3 kt by m. Here 3 by, we have to multiply to the numerator and denominator by 2 inside the root and keep root 3 by 2 outside, into remaining term root 2 kt by m. Hence under root 3 by 2 times most probable speed. Now simplify under root 3 by 2 and it is to be 1.225. Hence average root mean square speed is to be how much? That is VRMS equal to 1.225 into most probable speed. That is the relation C. And from these three relation, we show that the most probable speed of the molecule is always smaller than average velocity or average speed. That average speed is again smaller than VRMS, root mean square speed. It means the root mean square speed is highest in comparison with V bar and V most probable speed, and that is the resulting term under the Maxwell-Boltzmann distribution law in terms of molecular speed. Thank you.